We'll continue in this video with Larson chapter 4 section 1, which is on antiderivatives and indefinite integrals. And in exercises 9 through 14 we want to learn to rewrite these integrals in a simpler form that is easy to apply our strategies for finding antiderivatives. So just as we did with derivatives, it holds true that often work that you do before you begin the integration process may save you a lot of time in the end, or may be essential to you finding the answer in the end. So for example, with the first, we're going to rewrite that as integral x to the 1/3 power, and then we can simply increase and divide, and so we're going to get x to the 4/3 divided by 4/3. So that would be x to the 4/3 divided by 4/3 plus c, and simplifying, that's 3/4 x to the 4/3 plus c. Now you don't have to write divided by 4/3, you can directly multiply by 3/4, that's fine. With the second example, we will rewrite that as x to the -2nd power dx. We're going to increase, we'll get x to the -1st divided by -1, of course, plus c, which is the same as -1 over x plus c. Number 11. Well, for this one, we're first going to have to multiply the x times the square root of x. And x is x to the 2/2 power times x to the 1/2 power. And so that would be the same as x to the 3/2 power. Since it's in the denominator, we're going to make that x to the -3/2 power. So that simple rewrite makes it a much easier problem. For the integration, we're going to increase by 1, so that would be x to the -1/2 power divided by -1/2, or -1 over 2 square root of x plus c. So x to the -1/2 is 1 over square root of x. Sorry, that's not correct. So dividing by 1/2 is the same as multiplying by 2, and so instead we would get there -2 over square root of x plus c. And you could leave the square root of x as -2 times x to the -1/2 power. That would be okay. All right, number 12. Right now we don't know how to we don't have a product rule for integrals the way we did with derivatives, and so instead we're simply going to multiply this out, and we would end up with integral of x cubed plus 3x dx. Integrating, we'll get x to the 4th over 4 plus 3x squared over 2 plus c. I can see that I forgot the plus c in the example above. So there's not a whole lot that can be done to simplify that. I could factor out, or I could multiply. Actually, I wouldn't want to multiply, but I could factor out a 2 or a 4 there. But I'm just going to leave it as it is. 1/4 x to the 4th power plus 1/3 x to the 2nd power plus c. And so that's how we would take care of that one. The next one, you have to be careful in rewriting that. You'll have integral 1 over 2 times x to the -3. So remember that your 2 remains in the denominator, and the x to the 3rd power can be moved up to the numerator with a negative exponent. And we're going to increase, so the new exponent will be -2. Divide by -2. It's the same as multiplying by -1/2, and so that will give us -1 fourth x to the negative second power plus c, and that'll be the same. Negative 1/4 x to the negative second plus c. So the simplifying and the integration can really be combined into one step there. There are no hard and fast rules on what you have to do. You can skip steps without causing any problems. So with this number 14, what I would suggest doing is first multiplying out. So you're probably going to get integral of 1 over 9x squared. Sorry, that's 9x to the negative second. And now we're going to increase. We'll get x to the negative first divided by negative 1. And so we'll end up with negative 1 over 9x plus c, which is the same. Negative 1 over 9x plus c. Negative 1 over 9x plus c. Alright, so that does it for these. So again, remember, whether you are converting rational exponents or converting radicals into rational exponents, converting converting rational functions into functions with negative exponents, or some combination of the two, as in problem number 11, whether you're multiplying out in number 12 or number 13 using remembering that any constants that are in the denominator have to stay there, even though you make the variables, rewrite the variables with a negative exponent. And then number 14, first multiply out, leave the constant in the denominator, and move the variable to the numerator with negative exponent. But those are things that you're going to use often in integration. Okay, that'll do it for this video.